Welcome back to the channel. In this video, we are going to discuss about the problem statement of reversing the linked list using the recursion way. Okay. So in the last video, we have discussed about how to reverse a linked list using the iterative solution. So in the iterative solution, we applied this while loop to reverse our linked list, right? And this is the linked list, original linked list that we got 6124 null, and finally we reversed it back and we get 4216 and null. So today we are going to discuss about a recursive solution for this problem. Okay, if you have not seen our iterative solution, you can see that in the link below in the description I have provided. Okay, and also the link to the playlist is there for interview coding questions that we have done. That will be very helpful for if you're preparing for product-based companies, or you are doing BTech and you want to have some placements. Okay, so let's begin. Now, first of all, whenever we are doing any problem using recursion, we should not jump into solving a big problem. Okay, now this is it's not quite a bit big linked list, but still it is a very big problem that we have 4 elements and we have to reverse. So what can be the small problem for this? So let's analyze it. Okay, so here I take 1, 2 and null. Okay, now this is a very simple problem. We are having only 2 elements in the linked list and we have to reverse it. That's all. Now in recursion, if you can solve a smaller problem and if you can generalize that logic, or if you can derive the logic for solving this problem, the problem will be solved for a bigger one also. Okay, now how will it be solved? You don't have to worry about, because it all depends on the faith on that thing. It's actually in programming world, it's called recursive leap of faith. Okay, so you have to place that recursive leap of faith in the recursion, but you have to derive the logic from the smaller problem. Okay, so we have a smaller problem of 2 elements where we have to reverse them. Now when we reverse them, currently head is 1. Okay, you can see head is 1. Now after recursion, or sorry, after reverse, what will happen? Head will be equal to 2. So, and 2 initially was, now don't say 2 is second element, it's the last element. Okay, that's where we have to focus. So basically what we have done, we have made the last element as head after we reverse the linked list, right? So basically using recursion, first aim we have is we have to reach the last node so that we can make it the head, and this time we have to shift our head rather than creating a new variable that first points to head and then shifts. We have to shift, or we have to iterate the head only, but in a recursive way, not in a iterative way. So how we will do that? But before we do the recursive way, we have to think of a case that when we will know that our last element is, we have reached our last element, right? So you can say that if head dot next equal to null. Okay, if head dot next is null, right? So we will know that, okay, so heads next now will be equal to null. So this means we have reached, or our head has reached to the last element or last node. So as you can see from here also, it's the last element is pointing to null, right? So in recursion, as there is a base case, so this is our base case. This is the base case, that if head is equal to null, what we have to do? We have to return the head. Alright. Now we cannot return null. It's no of use. So basically we will be returning the head itself. So we will be returning the last node, and this will this will be the new head for our linked list that we want. Okay. Now the linked list that we want, I write here 2, 1, and this one points to null. This is the expected one. This is expected, right? Now we are when we are going to the 2 and making it the head, it's fine. But since links are not joined, then how we will be traversing from 2? So that's the problem. So basically we have to change the links. So how do we change the links? So here first what we will do is we will create a new head variable and we will store this last node. So before we store this, we have to iterate also to the last node. So how do we do that? Since we are using the recursion way, we will say reverse. This reverse is a function and it will take an argument. We will say head.next. Why head.next? Because we need to change the head. We need to move forward the head. So initially we will be passing head to the function, and then within the function we will be calling this, we will pass head.next. Okay. So every time it will continue to call till we get the last node. Once we get the last node, okay. Now as we call for this function, as we call this, what are we going to give? It will say reverse of head.next is 2, because our current head is 1. We have still not get to 2. So our current head is 2. Now for 2, this function will call itself. So the base case is that we have written is head.next equal to null. This condition is true. So it will return head. So it will return 2. Actually it will return a node, last node, but for understanding, let's assume it is returning 2. Okay, for representational purpose we are using 2. Okay. Now the new head is 2. So we will store it, and we need to return this also. Okay. So before we return this, we have to make certain links changes. So first link change will be, we will take a head next. Head next, as the name suggests, is the next of the current head. So head.next. Now we are not interfering with the new head variable, because we don't want to interfere there and mess up. We are using a new variable. So we are storing the next value of our current head into head next. So our current head is 1 and we are storing its next into head next. Then we need to make its next point to head, to its current head. So after this statement, what will happen? Currently head dot next, or you can say that head next will be having 2. Now after this thing, what will happen? 2 is going to point to 1, and then we will say our head equal to null. So 2 is pointing to 1, 1 is pointing to null now, right? And we will say return new head. That is our last node, or the new head node. Okay, that's very easy, right? So that's how we are going to reverse it. Okay, fine. Now this is the logic that we have built for this simply linked list, this simple linked list, 1 comma 1 points to 2 points to null, and we get this expected result. So now we need to write the same logic, and this will be the same logic that we apply for any linked list. So let's write down this logic in our code. So I will create a private method. Why private? Because you will know why we are using this private variable. Okay, and I will say reverse recursive. Let's name it, and we will pass a node. Okay, now first is our base condition. So as we have seen that our base condition is to check head.next equal to null. Then we have to return null head. But in case our head can also be equal to null. So to check that, we will say head equal to null. If our head only becomes null, if our initially the linked list is empty, so that is also a corner case. Then also we have to handle, and this is our normal case when head.next equal to null. So in both cases, we are going to return head. Fine. Okay. Now, as I have said, we will be implementing the logic that we have discussed. So this is the first line of code that will give us the new head, or basically this function will traverse till the last node, right? Now what we have to do, we have to take another variable head next, and we have to make it node dot next. Now we have made a head variable, as you can see here. Where we have made, this is the head variable. So we will be passing it this head to the method when we will call it. Okay, that's why we are not using head.next. We are using node.next. Okay, then node.next, oh sorry, head next dot next equal to head. Okay, and finally, or we can say it should be equal to node. My mistake. And we have to make node dot next points to null. And finally, we will return the our new head. So now earlier this was the head, 6 is the head. Now finally we are returning 4 as the head, and we have changed all the links, and now we can traverse using this head from 4 to 1, 6 and null, right? We have a print method. As you can see, this is the print method. So we will be using this method to revert. Now to call this method, we will create a public method, public void reverse recursive. It will take nothing. It will just say head equal to recursive node head. That's all. That's all we have to pass. Okay, fine. Now let's try to run it. Now this, let me comment this out first, because we don't want the iterative solution to work right now. So we are using this method, the public method list dot reverse recursive, and then we will write list dot print. We will print the list afterwards. So let's see if it works fine. Okay, here comes a null. Wait, where is the problem? Let me see. Okay, so the problem was in our base condition. In our base condition, we wrote head equal to. We used the head variable, but we have to use the node variable. So that's all my mistake. So sorry for that. So now we are getting our linked list here. As you can see, we have called the list reverse recursive method, and we successfully printed and reversed our linked list. Okay, so that was how we reverse it. Now the time complexity of this will be big O of n, and space complexity will be also big O of n, and this space complexity will be due to the recursive stack. So whenever we call the recursion, there is a recursive stack or function called stack, where function continue to call till we don't reach the base condition. Okay, so it is due to recursive stack. So if your list is of type, or if your list is of size n, then it will call n times this reverse recursive will be called till we get the last or the last node, and then the base condition will arrive, and then the recursive stack will continue to decrease the stack size. Okay, and for this this one time will be big O of n, and space will be big O of 1. So it's preferred to use iterative solution, but you can use recursive solution if you want. But although in terms of space, this is the and time both, it is the most efficient solution, right? So that's all for this video, and we will see in the upcoming video how to use this reverse methods or this reverse logic in solving some of the big problems and some of the complex problems. Okay, so that's all for this video. Till then, bye bye.